All right, guys, good afternoon. Today, as planned, is just going to be a work day in you getting ready for your Unit 8 test. Um, is going to look a lot like the quiz, except with just the added topics that we've done since the quiz. So I just want to kind of take this time to review the formulas that we had, and then just take any questions you have on anything. So we started out this unit first talking about area between curves. And we had kind of like two formulas for area, whether we're doing it in terms of dx and dy. Things I would expect you to know how to do for your test tomorrow is, of course, finding the intersection point still, either by hand or with the calculator. And then also when to determine when you're using more than one integral. That seemed to be not like a common mistake, but it is kind of like a major mistake when it's made. So just kind of make sure you kind of review over that of when an area would require two integrals or when it would just require one integral. And then we moved into volume. So the second topic we talked about this unit is volume by cross sections. We know the formula is going to be the integral of the area of a cross section, and we can do that in terms of dx or dy as well. Area formulas I would know for your test tomorrow. You can kind of see them listed, but the area of a square, a rectangle, semicircle. We have two types of triangles, and then if it just gives you the area directly. And then after the quiz, we looked at volumes of revolution. There's two volumes of revolution. We have the volumes by disks, which we are going to use when there's no gap between the region you're revolving and the axis that's being revolved around. And then also the washer method when there is a gap between the region you're revolving it around. When you make these regions, it's kind of rotating around. So that's why the formula looks a lot like the area formula for a circle with that pi r squared inside of it. And then the last thing that we did on Thursday was arc length. We had two formulas, whether we're doing it in terms of dx or dy. In both of them, when you are integrating it, you will always integrate it from the smaller number to the larger number. We'll never have a negative arc length. And the formula is actually based off of the Pythagorean theorem. If you're doing it in terms of dx, you're going to find the derivative of y with respect to x. Again, those dx's will always kind of match up there. If you're doing it in terms of dy, you're finding the derivative of x with respect to y squared inside of the formula. And of course, when I say dy dx, that's going to be the same thing as like just saying y prime. When I say dx dy, that's like when you solve the equation for x and then plug in x prime. Because of the shortened periods tomorrow, it is a Wednesday. You're only going to have 40 minutes for the test. So I did make it like it is going to be a 40-minute test. And in that 40 minutes, it is going to be a lot more of just like setup, and not a whole lot of evaluating, just because we don't really have time to do all of that. But those are the formulas you need to know. It is a pretty straightforward kind of test, I think, because it is a very like formula-based test. Things you definitely want to get done. This unit had several required homeworks. The required homeworks were homeworks 1, 2, 4, 5, and 6. The optional ones were basically homeworks 3 and 4. Those are the AP problems. Again, they are optional, but there are a lot of good practice problems on homework number 6 that will look similar to some of the ones you will see on your test tomorrow. And then you have the quick reference, the summary, the multiple choice review, and the quiz corrections from the briefcase binder. I know many of you started this on our last workday we had on Wednesday last week. But again, that's just the other portion I would expect you to kind of finish. Would not, excuse me, would not expect a super long summary because this unit is a short unit and it is very formula based. So you should still have like a complete summary, but I honestly am not expecting a summary to be very long. That does save you some time in completing the briefcase binder. So that being said, like it is a work day, but I did just want to kind of use this time to take any questions that you had on anything. Again, like if you just want to go ahead and get started working, you can. But right now, kind of will open up for questions on like homework questions, questions from the quiz, questions from the briefcase binder, questions on just like content or topic wise. So yeah, what questions do you have, if any?
Homework 7, number 34.
Homework 734.
Yeah, I didn't know how to start it.
So looking at this one, we do want to be able to try to figure out like what this graph looks like. And honestly, I should have put the graph here. This is partly my mistake. I'll go ahead and do that now. I'm going to use Desmos to graph it. I don't have the screen up right now, but it forms, again, a shape that you're not expected to know. And I actually think it was in the textbook, and when I copied it over, I cut it off. So I'm going to add it right now. So again, you would not be expected to know what this graph looks like. I don't know why my computer is running slow. Whatever. I don't know why my copy paste is not working, but it looks something like this. It is a very symmetrical one, so it's symmetric about the x-axis, the y-axis, and even the diagonals, even though my drawing does look pretty terrible on it. So basically ask you to find the perimeter of it. I would recommend you find the length of one curve and then basically just multiply it by 4. So like if I'm looking at this one, I'm going to go ahead and just do it in terms of x like we're used to. So I have like y to the 2/3 is equal to 4 minus x to the 2/3. How do I get rid of that exponent when I'm solving for the y? I can raise both sides to kind of that reciprocal of the exponent, so kind of raising it to the 3/2. So I get that y is equal to 4 minus x to 2/3 to the 3/2. And be careful not to distribute that 3/2 across. And so if I'm doing this in terms of dx, then the length of just like one of them is going to be the integral, and I'll put those numbers on in a second, the square root of 1 plus the derivative squared with respect to dx. And again, the derivative, making sure we do the chain rule, 3/2 minus 1 is 1/2 times the chain rule. So there's the derivative. And again, you can simplify this. This one you definitely would have to evaluate in the calculator, so it might actually make sense to simplify it just a little bit, only because the calculator can take a while when you have a complicated integrand. So like I can kind of visually see the 3/2 and the 2/3 are going to cancel out. And so I end up having this as my derivative. And then we do also want to figure out like what this will look like. I can see the length of this is starting at the x value of 0. Again, you could look at the graph carefully and see where it ends at. Good algebra just to practice here. If I want to find the x-intercept of it, well, plugging in 0 for y, you get x to 2/3 is equal to 4. So basically, x is equal to 4 raised to the 3/2. And if you're trying to figure out how to simplify that, the half is going to be like the square root. The square root of 4 is 2. So that becomes 2 cubed, which is going to become 8. So that is basically the integral that you're going to set up. And again, that's just one piece, the part that I have highlighted. Multiply it by 4, and that would give you the perimeter of the shape. But your question might have been just like, what did this look like? And in all honesty, this will not be a graph. You need to know what it looks like. This graph would have been provided to you. Any other questions or clarifications on that one? Any other questions on anything else?
Can you do part C on the homework 6 on the very last page?
Mm-hmm. So this is the optional homework, but part C on the very last question.
Yes.
So we have this shaded region bounded by the graphs of y is equal to x times e to the x squared, which is basically going to be this top one. I'm just doing all this because not everyone may have started out. The line y equals negative 2x, and then the vertical line x is equal to 1. So part C, we want to write but do not evaluate an expression involving one or more integrals that gives the perimeter of R. So if I'm looking at this one, if I'm doing the perimeter, we are going to have to look for basically 3 different segments of this one. We have like this integral, and then we have this integral. And then you also have this third side, which I probably wouldn't write an integral for just because it is straight up and down. So the first step is just to kind of find the different values that you have. So I'm just going to rewrite my functions below it, actually up here. So finding y prime of this one, because we know we're going to plug in the derivative, we have the product rule. So I have the derivative of the first times the second plus the first times the derivative of the second. There's the derivative of the line, and then we have x is equal to 1. So if I'm going to do the perimeter, and I'm just going to kind of write it up here just so I don't have to keep scrolling. The part in red, so it's going to be the integral. It starts at x equals 0, ends at x is equal to 1. And it's the square root of 1 plus the derivative squared. And I just simplified that derivative a little bit in terms of dx. Plus, then we have that straight line. Do you want to talk about this one? Like, this is technically a triangle, so you can get away with setting that one up without an integral. But again, you can use an integral as well. Like, it goes from 0 to 1 on the x value. The square root of 1 plus the derivative squared dx. I know that is just a number, but again, we could have set up that problem just doing like, here's the leg of a rectangle, here's another leg of a rectangle, and it literally becomes the Pythagorean theorem. Then this last section, this is a vertical line, and if I just want to find the length of it, probably wouldn't find an integral. Again, you could, but it's a little bit weird too. I know the length of this line is just going to be this top y value minus the bottom y value. Well, the bottom y value is when you plug in 1 into the bottom equation, so we know it's going to be negative 2. The top of the line is when you plug in 1 into the top equation, which is just going to be e. So what's the length of that vertical bar? The top y minus the bottom y. And that's the expression I would probably write to represent the perimeter of it.
So instead of writing the blue integral, you could have just written like root 5.
Yes, like that's what that's going to end up being. But yeah, where for everyone else see where that's coming from. So like if you're looking at just the right triangle, like this is 1, that's a negative 2. So instead of that blue one, you could have just written the square root of 5, which if you were to evaluate that integral using the calculus, like it's going to become square root of 5, but you could have just written square root of 5 as well because it is just a straight line, and we know how to find the lengths of straight lines without calculus technically. Any other questions? All right, well, I am here to answer questions as they come up. Class doesn't officially end until 1:10, so like I won't end the meeting until then. So as your working questions come up, please don't hesitate to ask them. If I don't get to your question today, then I am definitely available during office hours, and of course via remind or email if that's what you're more comfortable with as well. Those of you who will be virtual tomorrow, the test is going to distribute 5 minutes before class starts, just to make sure it shows up in time, and then it will close 5 minutes after class ends. And for everyone, there will be like a calculator and a no calculator section. Again, the main skill you want to make sure you know how to do with the calculator is how to evaluate integrals, of course, and then also how to find the intersection points. And just because of the sake of time, the vast majority of the test is going to be like just setup, 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 setup. Not near as many evaluating as there was on the quiz, because you will just have a 40-minute period. So I had to kind of adjust it a little bit for that. So yeah, I'll be here if you have questions to ask. Other than that, yeah, I'll see y'all tomorrow. But definitely get your questions answered if you have them.
Mr. Brown,
Yes, sir.
can you post the rest of the practice test answer key in OneDrive? I think there are only 2 pages in there.
Yeah, I didn't know there's only 2 pages. Yeah, I'll go back and fix that.
Thank you.
Uh,
Mr. Brown,
Yes.
can you go over number 2 from the quiz?
Yeah. One second, I'm just adding those keys to the folder real fast.
It's all right.
All right, Seth, all the answer keys should be there now.
Thank you.
And then number 2 from the quiz.
Yes.
Where you're writing it in terms of dy.
Mm-hmm.
So did you have trouble finding the numbers that go in your integral sign?
Yeah, I was just confused, like, yeah, just about like the whole thing, putting in y.
Okay,
'Cause, like,
so if I'm looking at this one, in terms of dy, we know we're going to do like the right function minus the left function. So like right to left and right to left, we see that the right function switches. So you will have to do 2 separate integrals for this one. So several things you'll have to kind of make sure you notice. Like there are going to be, of course, 2 integrals. The first one starts at the y value of 0, and we have to find kind of the y value where they intersect. And then plus the other one's going to start at that y value we find, and then end where that top function is. So different things we want to do. First, we have to find the intersection points and possibly like that y-intercept of the top one. And then also like solving them in terms of y. So this exponential one, I'll do that one first. We have y is equal to 4 e to the negative x. Dividing by 4, we have this. To get rid of an e, we do the natural log of both sides, which is just going to cancel out the e on that right-hand side, giving me negative x. So I have x is equal to the negative natural log of y over 4, or 1/4 of x. And that is this top function we have. And we can use our calculator to confirm that's the top one as well. The square root function, a little bit easier to solve. You can divide by 2 first, or square everything first. And we get x is equal to y squared over 4. So when I set this one up, before I go through and kind of find the numbers, I'm going to work from like bottom up. So this first region, right minus the left, the right function is the y squared minus 4. The left function is the y-axis, which is x is equal to 0. And then the next region, and there's like my blue line where I'm kind of dividing it, the right function is what is now a natural log 1 minus the left function, which is the y-axis, or 0. Then you do want to go ahead and find the intersection points. I'm writing on my Surface, and they don't have the calculator program on my Surface. But basically, you would find the intersection point. Make sure you don't use the x value, but the y coordinate of the intersection. And that would be kind of what I put in the box. And then the second integral is going to be where this integral ends at, which is going to be the y-intercept. So basically, when x is 0, e to the 0th is 1, so it's going to be a 4.
Okay.
Did that answer your question, or is there other stuff you want to look at?
I understand. Thank you.
Yeah, and the big mistake on that one that several people did is it has to be in 2 different integrals because the right function does switch.
Mm-hmm. Thank you.
Mr. Brown.